Hi everyone, and welcome to the webinar. We've got on assessment in technologies, and I know it's pretty popular because we've got about 400 registrations, so sit back and enjoy, because I think you're going to get a lot of ideas today, and we want to cram in as many as we can in the time we have. And I'm going to introduce Rebecca Vivian from CSER, and essentially, Beck, are you there, mate?
Yep, hi, thank you for inviting me along today. I'm so excited to present the work that Martin and I have been working on this year around assessment, and yeah, we're hoping to make this practical and so you can walk away with some great ideas for your classroom.
Fantastic, and I've just got a slide here, Beck, of the people who are involved across the states and territories. We've got some people all across Australia and from New Zealand, so we better be good. Okay, let's get started. One of the things we were talking about earlier was that, you know, how do people feel about assessment? And, you know, you might be able to associate with where you are at the moment with some of those emojis. I'd like to be the guy with the sunglasses on because I want to go on a holiday, but that's not really got to do with emojis and assessment. But think of yourself and how you're feeling: confident, happy, looking forward to the challenge, or a little bit demystified or not sure what to do. So have a think about which one really you associate with. Today we're going to really look at some digital technology sequences and some ideas about teaching digital technology. So we try to choose a range of different content areas and some levels across this F to year 8. We want to show some examples of some relevant tasks, and also what we really want to do is bring out the thinking, Beck, don't we, behind the how to do the assessments.
Yeah, so we're going to present the lesson idea, but we'd like you to keep an open mind. So think of how you might take that idea and apply it to a different context or a different topic within digital technologies. And then we'll walk through ways that you might assess that activity and some of the thinking behind the frameworks and the ways that we've been developing assessments here.
That's right. And so if you're thinking about the analogy of teaching you how to fish, we're going to give you a few fish today, but we'd like you to be able to take our ideas away and, you know, come up with your own assessments and adapt them. That's the whole idea for today. I thought we'd start off by looking at algorithms, because that's something that's sort of common across all the year levels. And, you know, it's a foundation area to start with. So one of the sequences we've got for F to 1 is the sequence you can see about algorithms. So you're basically starting about following instructions. You know, can they then describe a sequence? And we're introducing a robotic device like Bebot or Bluebot, and then some algorithmic thinking to apply. So that's where we're looking at. In the first instance, the example we've got here is a slide sorter. Goldilocks and the Three Bears is the story, and the students have to put together in the correct order these slides. Now you might be able to see there that this one's using PowerPoint, it's a presentation slide. So there is a bit of ICT capabilities in there. There's also a bit of literacy that you could sort of look at. Beck, what did you want to say?
Yeah, so here we're sorting slides within a presentation software. It could be even just sorting paper-based pictures. But if we're using presentation software, that's a great chance to, in your thinking, break up what are you assessing for ICT capabilities, what are you assessing for digital technologies. So thinking of ICT capabilities, that's you're using technology effectively. So that's things like, can the student navigate the presentation software? Are they able to save a file, open a file? Can they use the peripheral devices like the mouse and so on? In your digital technologies, we're looking at the discipline content. So there we're thinking about their understanding, their deep understanding of algorithms, so sequencing and logical sequencing in that regard in this sorting the slides.
And then if we move on, so what you might then do is have something like, you know, you could use Rosie's Walk, or here's some examples of what we've got there, but we're asking students to use arrows or some sort of symbol to talk about directional language. You know, it could be forward, right, turns, and so on. So here's an example with the story with a map. that you might ask students to fill out, you know, get the wolf to wherever part of the story that they want to get to. And in this one, you know, are they using forward, or do they actually shorten it and say six steps forward or 6 arrows? What language are they using? What ways are they using to show the directions?
Yeah.
Yeah.
So there's lots of different things that you could look at there. So as a teacher, if you're thinking about your assessment, you don't just assess the one summative task. You're thinking about trying to embed assessment opportunities throughout across multiple learning activities. So this might be one in a number of algorithm activities. So you're thinking about ways that you can also collect that student data so that you can collect a series of data points that help support you in your reporting. So in this example, if students are playing with bee-bots on the ground, you might be taking photos, video footage, or getting students to record and take photos themselves. You could be sitting alongside them and asking questions to elicit their understanding of what they're doing and how they're navigating through the maze. You could be using things like checklists and rubrics to evaluate their understanding, which we'll go through in a second.
Could also be that you might have sort of a pair working together, and then they come up with their coding, and then they give it to another group, and they sort of decode it and see whether that map actually works properly, if there's any errors or so on. So that's a good way you can get groups together to work.
Yeah, and as well, that really brings in that, I like the idea of peer assessment. So they're checking each other's algorithms to test each other's knowledge, and they actually become the assessors.
Good idea. Yeah. So, Beck, you want to take us through this section?
Yeah, so in this one, we're just drawing our attention to the achievement standards. So when we're thinking about assessment, we really want to come back to the achievement standard and the content descriptors and focus on the key verbs that we're looking for. So, for example, in this activity, one of the achievement standard text that aligns with that is the idea around students design solutions to simple problems using a sequence of steps and decisions. So there we can focus on the key verb design. So we're really looking at how students design their solutions. And so from that, you might consider activities that enable students to demonstrate how they're designing their solutions. So as Martin mentioned, bringing in sequence cards where they can demonstrate the order of their algorithm, as well as if they're using any flow charts or any verbal instructions that comes into play in designing their solutions.
Yeah.
So when we think about assessment activities that go along with that, you want to provide multiple opportunities where students can demonstrate their understanding. So you might get them to go through one example of navigating the bee-bot, perhaps in a literacy activity where they're going to spelling words and you're monitoring their understanding, that they understand how to navigate and create the algorithms. But then you might apply it to a new problem, so perhaps within a mathematics context where you're getting them to navigate shapes, or even in a new literacy context where students are navigating those story events within a story. So it's really just providing multiple opportunities where students can solve problems across different contexts and just demonstrate their skills.
Yeah. Also, just picking on that design element, I mean, you might get sort of kids at year 2 who can design their own little game, and for example, like bee-bot moving around a grid, and then you might associate points with making words or going through stars, picking up points, and they can design their own game and talk you through then how they've made that game and what language do they actually use.
Yeah, and in terms of progression as well, you could look at how students, the complexity of their solutions. So perhaps, can they get from point A to B, but then when you've got obstructions, can they find the shortest path, or have they just found a path? And so you could sort of start to break up what you would expect to look like the complexity of their solutions as well across that.
Excellent. Yeah, and so we've got a SOLO taxonomy example.
Yeah, so one way of looking at assessing their understanding, so looking at that progression of complexity in their solutions, you could use something like a rubric. So in this case, we've been working with the Digital Technologies Hub to create them around using the SOLO taxonomy. And this is a way of looking at how students go from one idea up to an extended way of thinking. So in this one, can students follow a series of steps to complete a task? We've identified that as the basic. Then the idea that they can then represent their algorithm as well as navigate the robot. And then the next one along is that they can create an algorithm to control a robot, so actually combining them together. And then on the next level, thinking about debugging. And so we're trying to identify what does the progression look like, what do we expect in the layering of skills as students move through.
Yeah, terrific. All right. What I want to do here is just get a data example, because we talked about programming, but essentially there's, just to let you know, there's a handout that we've got there, which is a lot of this information we've got, what Beck and I are talking about. So the examples that we've got is on the handout. So if you download that handout, you'll have that to go through as well. And we'll also make the slides available at a later stage. But getting into the data example here, so collecting and organising data is part of this sequence. And let's have a look at this example we've got here. Using the context of biodiversity of the school ground, we looked at different garden beds and what was the diversity there in terms of plants and animals. So the students there, the first thing what was asked to do is, and here's quite an interesting example of representing data. So one of the important parts is, when we're looking at data, is we might represent them as symbols. So one obvious thing is when you're looking at the weather, you know, how do you associate symbols with clouds, the sun, wind and rain and so on? And how do we recognise that? How do we know that that is a cloud? And it's looking at those sort of aspects of digital technology, the skills of representing data. So here's 4 students' bits of work. A ladybug, you can probably work out, a worm and the ants in the other pictures. So you might say, well, where's the 4th ladybug? I think it's flown away. But there are some examples of some students' work there. Now, how do they make those representations immediately recognisable? So they've looked at the features of these animals, they've looked at the colour and used that. And you can see there, each one's got a slightly different representation of it, but you can immediately recognise, in most cases, what that animal is. So I think one of the things is, when you're talking about representation, is to talk through and how do we make sure we recognise these, the symbols and whatever we're creating in terms of the data. And Beck, any ideas about assessing these things?
Yeah, so as Mike mentioned here, you've got can students accurately represent the data? That's appropriate to their year level, of course. You know, is it immediately recognisable? Can they explain and identify the features in their representations? So even multiple ways of representing it. So students might draw their representation, but also label it or write words that describe it. Here, you could be taking photos and talking across what are the ways we can classify these representations. So here you could talk about how many legs they've found the ladybirds to have, the ants in the other case, and they could compare and contrast representations between students. So in terms of this, students could do this as an individual activity in terms of comparing and contrasting their representations, or you might run it as a whole class activity where you're getting the whole class to you know, look at all the collective representations and try and have a discussion around that. So to support your assessment of student learning in that instance, you might be using a checklist and just quickly checking off indicators that students are understanding what topics, what knowledge and skills that you're wanting them to display. You might be checking that off as you go. You could be asking questions of the students, getting them to ask questions as well to try and understand what their level of understanding around representing data is. So I think on the next slide, we've also got a bit more of an example where you could take this activity and expand it.
Yep. Just got to make sure I've got to get us off the screen, sorry.
Okay.
Just hang on a sec. There we go. Sorry, there we go.
So that's all right. So in the previous example as well, you might be getting students to document their learning on worksheets. They could be taking photos and comparing them with the drawings that they've made. And they could be creating a portfolio of work around collecting data about their garden. So then when we think about coming together, you could have students all collectively curate the data that they've collected and try to analyse it to understand what's really happening in their garden. And then in this example, Martin, you've got multiple representations. I thought you'd like to talk through that one.
Yeah. So obviously with the, I've got a phone call. There we go. Get away. That was our phone call going. Sorry about that. Yeah, so this is representing data. So you can see there, one of the types of ways is obviously a table with, and we've got representing the data with numbers. Sorry. And that's what happens when you share a meeting room in an office. We've got using images of our trees and so on, and also using some symbols there with a block. So that's representing the data, and presenting it. We've got the table, we've got the picture graph, and we've got a bar graph. So basically we've got some different ways to represent and present the data, and then obviously in terms of assessing, we're trying to look at how the students are, putting that work together.
So you can be looking at like what data are they looking at? Have they accurately measured that data? Are the way that they're presenting data, does that make sense to the audience? So when we think about digital technologies, we present data to a user. So you're really thinking about, is it easy to interpret for the user? Do they understand it? Have they been able to think of different ways to present that data as well? So on the next slide, so in those activities, we're really thinking about the visual aspects of representing and presenting data. But when we go to the achievement standards, you'll see that explain is the key word there that we're looking at. So explain how the same data sets can be represented in different ways. So in the learning activities, they've enabled students to represent the data in different ways and provide a context to collect data and present the data. But the achievement standard is for this year level is we really want to understand how if students can explain what they've done as well and the process behind it. So when we look at this with the work that I've been doing with Martin, we've taken the Bloom's taxonomy as a way to generate ideas. So when we think of explain, that falls in the understanding category of the Bloom's activity category. And what we can see is if we look across at ideas that in your handout that we've linked to, there will be sample assessment activities. So if we're thinking explain, it could be things like students alongside the work. So if they've done their presentation of data, they could also provide an oral presentation describing the things that they found in the garden. They might create a video where they're walking through the garden and showing images on the video of the representations of their data. Or you could also do it as a whole class or a small group focused discussion. So you could be talking with students to get them to explain the work that they've created on their paper there or in their videos or photographs. So we're trying to think of ways that we can, opportunities where we can create students, enabling them to explain what they've done as well.
I think we just had a really good comment or question in the chat, Beck, and that was about, we know this sort of activity would link to maths and to science. So we can obviously look at some of those examples in what is the science aspect that we're looking at, and that might be more about the biodiversity and trying to understand what the data is telling us, and the mathematics that has that sort of presentation of data as well. So as one of the questions there is, how do we assess digital technologies in terms of what we're looking at as compared to the maths and the science?
That's a really good question. I guess there's two parts there. I'd say that the assessment approaches that you're using in other learning areas, you can really harness them and use them in digital technologies, because you already have the expertise as teachers, and assessment is not a new thing, but it's just looking at the content descriptors and the achievement standards and of the digital technologies curriculum. That part's new. So we could, if you're looking at the achievement standards for digital technologies and you're running a unit of work or a lesson that aligns with other subject areas, pulling out their achievement standards and the content descriptors and looking across them and thinking, what kind of activities can you do that enable, to address a number of different achievement standards. So you might find that this achievement standard of explaining some of the data sets lines up really well with those in mathematics within the same activity.
Yeah, I definitely think it would line up with the mathematics, and I think the science, aspect to it would be analysing that data and then trying to come up with scientific, examples in terms of why wouldn't there be much biodiversity at one particular area compared to another.
Yeah.
So you might do some science investigation out of that using that data, making claims about that data.
And it could be extending the task to sort of address some of the extra parts. So maybe the mathematics, they've presented their data. Can they then synthesize that data, and in their explanations, have they got that mathematical thinking behind it, and can they explain it in that mathematical way as well?
And also, like mathematical, we're in both areas, digital technologies and with mathematical focus on data, we're very interested in, the way it's presented. So, is there an axis? Are they labelled? Is there a title? And all those sorts of things. So some of the things are quite shared as well. So we might move on to the next part, but there's in terms of digital technology, we've got a checklist that goes with that, basically about explaining the data sets, organising and displaying the data, presenting the data. So there's quite a bit of a focus there.
So with with the checklist, what we've done is we've taken the achievement standard and we've just broken it down into elements that we might be looking for. So we're not assessing things that aren't needing to be assessed or going off on a tangent. We've just really focused on what are the key elements that we're looking for, and we think it's around explaining. So can the student explain, and we've unpacked maybe a couple of things we're looking for there in their explanation, and as well as their ability to interpret and organise and display the data. And we've unpacked what we think might be some key things to look for again, as well as the presentation aspects. So we're just trying to keep the checklist simple, but also leaving space for comments. So you might identify opportunities where you might adjust learning and teaching activities in the future, or where you can provide some feedback.
Yeah. If you've got any more questions, we'll put them in the chat and we'll talk through them. Again, this is just another version of some different ways you might see that students present some information, and talk through, I suppose, as a group, as a class, what works well, what doesn't work well. So then you can sort of assess some of these things. So again, it's a nice area to have a look at in terms of assessment. Might just move us on, Beck, in terms of the next section. And we're looking here at year 5-6 at binary, using zeros and ones and using that to do some representing of images. So you might think, well, how do you do that? Let's have a look. So in this case here, we're just using zeros and ones, and you might be able to see from the image what does 1 equal, black or white, and what does 0 equal. So basically 1 is 1, we're talking about the light, so 1 represents white, and then 0, no colour, represents black. So you can see how that images is made up, can be made up using those those numbers. So you could get, for example, students working together to create their own, code their own grid, and then pass it on to a student and see if they can decode, come up with the black and white image and see if it matches. Again, that could be used as an assessment. It could be just a task there. And again, I think this one here we'll look at, you know, behind that, can they explain what's going on? One of the things when you do ask this sort of students to do this sort of work, you know, 0 and 1 makes black and white. Well, how do you make colour? And that's quite an interesting thing. So you can do that reasonably simply with 3 colours. You've probably heard of RGB, and basically you can see on the screen here for red, if you write that as in 3-bit code there, it's 100. Again, there you can see blue and green are also represented. So you can see the 8 colours there, and including black and white. And it's a really good activity to ask students to you know, create their own bitmap image using those colours and you're coding it. So we've got a little assessment task to go with that. So you could actually just do this even if your students didn't have much of an idea about binary and using the codes. But there's a great little website I'll put on the handout where you can basically go and the students could create their own little pixel image and play around with that 8-colour puzzle and learn about, you know, what is 001? Is that green? Is it blue? And to work through that process. So this could also work with Year 7 and 8 students to see what they know about binary digits and images.
Yeah, and so in that activity as well, they've done the practical processes skills of being able to convert binary and represent their images. But then looking at the achievement standard, it asks them to also explain how digital systems use whole numbers as a basis for representing a variety of data types. So there we also want to complement the hands-on practical activity so that you can sort of bring to life the processes that they've put in place to create their images, as well as their deeper understanding of how that all works. And that might have been, the content knowledge might have been led up to that activity. So you've obviously, you know, done a bit of work in working with students to teach them about how binary works and how images are represented. And then you've now got that practical activity. So the assessment that goes with that, you know, is thinking about ways to provide opportunities, the ability to explain and articulate what this is all about, what they've done. So you could ask them to do a presentation or a demonstration, or perhaps some written text that goes along with what they've done. So you might be, to evaluate their understanding, you could use something like a checklist to sort of check along those key elements that you're looking for. This is available on the hub as well, so there's a checklist ready for you to use with this activity. And you can see there it's also got a little bit of detail that Martin's included that helps you sort of go through and just check that students are understanding what this data representation is all about.
I think this really, to me, brings up a good one for formative assessment, Beck, because the students could be using this puzzle. You could go around, you could ask them questions, you know, how can you make, you know, 0 red, what are you using? You know, you can get some feedback. If they've got no idea, you could sort of start to help them out. And it's a very easy puzzle to work through. So, you know, I think it's a really good activity.
You even could think of like a context where they have to explain data representation or binary to their grandparents or something like that. And so, you know, can they articulate that in a video to someone else in plain language? Yeah.
And just as I mentioned before, you could do this with Year 7 and 8. And interestingly, you know, you just mentioned there, explaining in a different context, you could say, well, how images out of a newspaper, images, you know, in a photograph, images in a video, how does it work? And so you can unpack that in a bit more detail. But in Year 7 and 8, you would expect probably them using binary in a bit more complex way. So, you know, a 24-bit colour gives us an enormous range of colours. And you can see there the RGB, that's a photograph. We can see it zoomed in, and that would have the numbers for each pixel has its own colour, and that's how it works. But that 200 or 74 or 78, that's the binary number, and then you can, in year 7 and 8, we could work out what that binary number is in 8 digits. So again, you can use this example in terms of assessment with your students. So exciting stuff, I think.
Definitely. So we just had a question come through. Someone's asked, are these resources available on the CSER MOOC? So I'm from the CSER Uni of Adelaide project. We've run free professional development for teachers as well as online courses. So the activities we're going through today are directly from the Digital Technologies Hub. So you can go and look at them straight away after this and try them in your classroom. But the content knowledge that goes with that, our MOOCs would be really great for that. So they're called Massively Open Online Courses, MOOCs. They're free to enroll, and we go through all of the content knowledge around what is data representation, about how does binary work, what is programming, what is algorithms, and so on. And that lines up really well with the Digital Technologies Hub activities. So we've got links in the handout that you'll get with that as well. So that the two together go really well. So
if you haven't got the handout already, try and use the handouts functionality on our webinar at the moment, because you should be able to download that. If there's any problems, we'll send it out through the email when you finish the this webinar. Let's move on to this part is, I think, Beck, we just want to talk about the SOLO taxonomy. So each one of the sequences, if you go through the sequence on the Digital Technologies Hub, you'll notice in the little box there it says the SOLO taxonomy. And each unit, we've basically come up with a way to differentiate the task and show how the students might be progress their thinking through this sequence. So here's an example of the one we just did there, representing images in binary, and you can see there we've got from very basic understanding of zeros and ones. And Beck, you want to talk us through that?
Yeah, so in this one, we've identified that you've got the progression of knowledge going from just identifying to describing, then moving along to explaining as a more elaborated way of approaching that. Then you've got evaluation as the final extended version of that learning. So it's just breaking down the achievement standards and looking at what are those key progressions. What do you think should be, at the bottom end and the top end, and what are students aiming for in the middle? So we've used the SOLO taxonomy here, but you could use, any rubric. If you've got a rubric template that you prefer to use, you could do that as well. What I do love about the Digital Technologies Hub rubrics, you can download them in Word, and you're able to adapt them, so you can jump in there and edit them to suit your activity if you've tweaked it a little bit. But yeah, it's just thinking about what's the different types of knowledge, maybe the knowledge and the skills. So do they understand the content behind it, and do they understand the skills that are involved in transferring the binary?
Beck, we just had a good question there from someone in WA, and I should have said this is for Australian curriculum. So Australian curriculum, it talks about year 5, 6, you can start to talk about binary as a way of representing data in digital systems. I think in it's about year 8 in WA curriculum, it sort of brings that in. So that's where it specifically talks about in WA curriculum, you can bring it in. But again, if it comes in using zeros and ones, there could be opportunities there to discuss it. But I think in terms of when, assessing in WA, it's really looking at about year 8 level.
Mm-hmm. Yeah.
So just a bit of changes in different states and territories.
Yeah.
So the SOLO taxonomy, we're not going to talk much about it, but probably Beck, if you wanted just to mention quickly, what do those terms mean? Yeah,
so in the SOLO taxonomy, they just have those different levels. The first one is that the student perhaps hasn't quite got the task, but that the next one along is that they're able to achieve their level of understanding, but it's a little bit disconnected. the next level along, students are able to achieve several aspects of the task, but perhaps don't understand how everything kind of works together. And then again, further along, they're starting to link ideas and concepts and processes together, which is quite like getting to an advanced stage. I'd say that's a fully complete stage. But then the extended abstract is that they're taking it to a whole new level, or they're able to take their learnings and apply it to a completely new context. So they've sort of gone above and beyond what you perhaps expected, and they're able to think at that quite advanced level. But probably within that, you're thinking about your learners and what level they're at as well, so you can tweak it to suit your needs. This is a great one. So in terms of assessment, we don't want to just assess them at the end, but you want to sort of use assessment to inform your teaching practice as well. So within the SOLO taxonomy, our colleagues and I, we had some discussion the other day in our team training, and it's someone said quite a good point, is that it seems to be on the student, the onus on the student, but we can actually use this formative assessment as a way to inform practice. So, okay, perhaps a number of students are at that pre-structural level. What can I do differently in my instruction around data representation next time? Or can we do another lesson in between just to address some of the misconceptions that perhaps students are holding?
There was in the chat, there's a question or a comment. Is there some work that we're going to be doing around comments for parents to make it more friendly? And we haven't done that at the moment, but it is a good idea for us to consider, I think, Beck, in terms of, you know, what language can we use that parents can understand and, you know, work out what their child's doing. So it's, we haven't sort of done any of that work yet, but we will, given that comment, we'll sort of try and do some thinking around that. So when we do, we'll put it up on the hub. And there's also just a question about some of the lesson ideas and things. So it was basically if teachers find out things that work well or don't work well, is there a way that we could share that information? And we do that actually at the moment, in that if you've done a lesson, you can use our contact, which emails, and it goes straight to me. And you know, if you had a lesson that you thought, oh, if you could change it, here's what you've done, change it in a different way, we can add that to the lesson ideas, so we make them much more rich. And we've done that a few times with people sending in some photos of their students' work, or you know, telling us things that they probably didn't work as well. We're very happy that people adapt these lessons and use them as they need to with their students, and we just ideally would love to get some of that information back so we can make those lesson plans even better. So if you do have lesson plans that you've used and you wanted to update some ideas, send them to us through the Digital Technologies contact down the bottom there. So thanks for those questions. Excellent.
And if you've tried any of the assessment tasks and you want to share samples of student work, that would be great to share with the Digital Technologies Hub too. So someone just asked, would you say unistructural would be your C level? So if we're looking at the achievement standards, the achievement standard is the satisfactory level. So with the SOLO taxonomy, looking at it, I think you'd probably start to unpack your achievement standard around what is the middle ground, and then what is above and below that. But if you're looking at more a reporting sense for parents and the school, probably if you had your own rubric and you had the achievement standard as the middle, and figure out what is progression above and what is progression below. So perhaps SOLO taxonomy could be used as more that formative assessment as you go through the unit of instruction, so you can just sort of monitor different levels of thinking than reporting.
All right, well, we might talk about now programming projects, and you know, that might, a project when you're doing programming, it might take in more than one content descriptor. So in this example here, we've looked at, you know, they're going to be defining a problem, coming up with a solution, and you know, that might involve creating an algorithm and also incorporating some sort of decision-making, repetition, and user user interface. So there's quite a bit to that. So, you know, how would you go and assess that?
Yeah. So projects provide a fantastic opportunity to collect multiple data sources. So it's not just about the final project, it's not just about the code, but there we can see the key verbs is, you know, can students design? Can they incorporate these programming constructs? Can they incorporate the user interface design as well as implement the solution? So thinking about this holistic project, you could have students collect samples of their project over time as they develop it, and little artifacts, so they might have annotations of their designs initially and how that progresses. You could have them taking photos or video footage of how their project works. And in terms of perhaps a final presentation, they could do a demonstration, a pitch, perhaps to the user that they've created their project for. And as well as produce their design and planning documents to go with that. So as a teacher, you can collect these little artifacts along the way and sort of measure as students, measure checkpoints in their progression and see how students are going, as well as how they're incorporating your feedback into their future designs.
I thought a good example here, like say, for example, if you're using the BBC microbit and you're asking students to create a game, for example, in this case, the students created the simple paper, scissors, rock game. Now, you can ask them to do a little algorithm there, a little, you know, a design diagram, how is it going to work? So in this case here, the student said, oh, well, on shake, it's going to randomly select if paper, then something happens on screen. If it's scissors, then something else happens. And if the rock is selected, then, you know, you'll see something else on screen. So automatically we can see there that the students thought about the input, whether they know that terminology or whether they use that in the explanation. That's something to look to. The if-then statements, that's branching. So we've already got some examples here of students this would be meeting the 3-4 curriculum for a start. And then if they had repetition in there, that would fit the year 5-6 standard. But it's interesting just to talk through that diagram with students and see how they actually explain that. What do they know? The use of a project log is really useful. We sort of explained that in a few webinars before about using the microbit as well. But basically, it's a way that you can help have a discussion about what projects they've worked on and, you know, what they have trouble with, what challenges, what do they do well, what skills have they now got. So all these things are things that you would collect and ask the students to keep as a log, and at the end of the time, when the project's finished, then they could show you what they've done there. And Beck talks about a student interview, a think aloud.
Yeah.
I found those quite interesting, Beck.
Yeah, so think aloud. So as students are creating their solutions, or perhaps as they're presenting them, you can sit alongside a student and you might have particular questions that you're wanting to ask around what you're looking for. So you can ask them, oh, that's interesting. Can you talk me through how that part of the project works? Or what made you decide that? Or how does that work? Can you elaborate on that? So you might sort of give them some prompts so that they're talking to you about what's inside their head and their understanding of how it all works.
I just thought I'd show you this sample here. So for example, when a student might have started this project, a very simple way to do this would be 3 bits of code. If you press a button, you know, you get the rocks. If you press another button, B, you'll get the scissors. If you press A and B together, you'll get the paper. Now that's pretty low level programming, and it's all based on input. So they're partially meeting at the year 3-4 level there. But then, you know, they might build that first just to see how it all works, and then try and incorporate the next level where they're actually got the if-then statements, and they're using some randomizing, which obviously would be a lot more difficult to do. So it depends on where the students are at and how they find out how to do this aspect of the programming. But I thought I'd just show you a rubric which talks about, like, often we get students to remix. If you've done anything in Scratch, students might remix a Scratch project, or they might remix a BBC microbit project, or whatever coding they're doing. They might remix from someone else's work. And this rubric sort of looks at that in an aspect of, you know, if you've copied the existing program and made some changes, or, you know, you get some more points if you've done a remix and created their own program. If they haven't used our own program, they just created their own and they sought help, or whether they've created their program and then provided some help. So that's another way you can sort of differentiate between what students are doing. You know, have they acknowledged the creator if they've used it before? So, and what skills have they learned as they've done the first aspect of it, compared to, you know, they might have learned 5 skills or more in terms of, you know, creating their own game or project, whatever it might be. So again, a rubric's quite a good idea to share that with students, to say, you know, I'll give you 1 point for this if this is what you're up to, but, you know, here's how to get 4 points, and share that with the students.
And in that, Martin, you could also involve students in the co-creation of rubrics. So if you're thinking of a point system, it could be quite motivating to say, you know, what do you think would get top score in terms of working as a class member in the creation of a project? So identifying good practice. So that comes into your ICT capabilities of copyright, recognising copyright, acknowledging copyright. I like the idea around helping a friend. So that's, you know, being a team player, also providing feedback. So there's lots of ways that you can involve students. You know, what do you think would make a good person in a team to create a project with?
I suppose the other thing, we're talking about a team and, you know, kids working together. So it's up to the individual to actually collect their own evidence as well. But, you know, having a group assessment, you can sort of see another way of having just checking some of the information that you're getting from the different students in that group.
Yeah, and particularly because digital technologies, you know, if you're creating solutions as a professional, you're often working in teams. You know, being able to self-reflect and identify what things you felt you were good at and what things you could improve on. That's a skill that we want to build in students as well.
I just noticed we've got another point in the chat about, and it comes back to the way we're integrating our subjects, which is, you know, a great way to do digital technology. So it could be a combination of, you know, math, science and digital technologies, even design technologies. Then the question is then, how do you assess each one of the different ones? So a little bit like our maths and science question before. And I think, you know, I'll give you a chance to answer as well, Beck, but we're trying to sort of impress on you, like, to look at the digital technologies statements, the achievement standards, and then trying to work through what is the actual assessing in terms of digital technologies. So while you might look at the whole project and do some bits of assessment for, you know, it could be English or could be science, maths or technology, you know, when it comes to design, digital technologies, there's certain aspects of that we're using our achievement standards to look for.
Yeah, I think it's sort of, unpicking it, also using those achievement standards to keep focused. So if you're going back to that narrative activity with the BBOTs, you know, it's a literacy, English and digital technologies lesson. So you might look on the English side of, you know, can students, do they comprehend what the story is about? Can they summarise the story? Do they understand what the key events in the story are? But then their digital technology side is the sequencing of the story, the algorithms, the way they design their solution, the way they implement the solution. So you could, you've got that one activity, but just sort of pulling it apart on what the key elements are. And I think just focusing on those essential parts around the achievement standard text.
There's a great question there about, you know, we've shown a programming project, but if the students don't know how to code, how do we, you know, what are the first few lessons that we actually get that the kids to know what to do? So the suggestion is, do we, you know, go through coding as a lesson? I think, you know, what, for example, I've done one where with the rocks, paper, scissors project, and, you know, we talked through on an electronic whiteboard, and I moved the code, you know, talk through with students how do we make scissors and how do we do that. So that was quite interactive and engaging. Kids weren't bored at all. So the interactive whiteboard is quite useful, I found, to introduce the code. remixing is, you know, they might find some games that they've already seen from that other students have made, that they, you know, they're available on the web. That's why Scratch is really a great tool to use to start off with, because there's so many different community available remixable bits of code. But, you know, again, that's kids need to sort of get a bit of a start. So I say yes, try doing some coding if you've got some coding skills. Otherwise, you know, ask students to sort of look for some points that, you know, some other coding examples. I don't know, Beck, have you got some suggestions?
There's some great resources out there for starting projects. So even around Scratch, you've got Scratch cards, which give a setup challenge of perhaps some blocks that they might use to build a program around. You could even look at, say, something like microbits or Arduino. You might look for sample projects that are available that suit what you're wanting to teach, and provide that as a starting point to scaffold students through. And then from there, they could extend, you know, take the knowledge that they've learned and then create their own project.
Code Studio also has some really good like little courses that they could do. So you'll find some kids will just jump on and get it quickly, and other students might need a bit more support and guidance. And those tutorials were self-paced, and they can just go through that at their own time. So you might have in your own classroom, you might have kids doing various different tasks depending on their ability and their experience. Very good question. So one of the things I thought we could sort of look at in terms of constructing a robot, because that's something that is done, like, you know, a lot of schools use Lego Mindstorms or Lego EV3s and so on. So let's have a bit of a look at that. On our website, it's called Making a Difference, and it's in your handout, the link to it. But here's how one school has sort of combined digital systems and the defining and evaluating the coding or programming examples. They've sort of got A to E there in terms of, you know, what's an A and what's an E. Again, it's just an example, but it's a way of looking at combining two areas of the standards. One's about explaining and the other one's defining and designing. So this is how a school's tackled it. Again, it's probably worthwhile having a look at. What I wanted to show you here was just some examples about what that teacher has done in terms of getting students to think about, and so they can find out what students knew about the digital system aspect to it. So the parts and components, could they be able to match those components, and a discussion about what each one of those does. So that's pretty low level when we're talking about the Bloom's taxonomy. That's probably more about remembering. But they could put in describing, you know, what the parts do. Then they've got about the coding, explain each part of a code, what does it do. So, you know, they've obviously introduced the coding for the EV3, and do all students understand it? Again, that could be formative assessment. So the students who don't understand it, they could be taken through a bit more detail. The ones who do can be move on to the next bit. If you provide a bit of code, here's an example with the EV3, but, you know, we could do this with microbit, we could do this with Scratch, whatever programming environment you're using. Could be dot and dash, doesn't matter. You know, it could be done on an iPad, could be a screen grab of that. It could be, you know, you could use this in a quiz sort of thing, A, B, C, which one is it, what does it do? So just sort of ideas about how you could sort of incorporate, you know, assessment in terms of the programming.
I think what's great about that is that often if they're doing these programming robotics projects, they're working in teams, like they might be working in teams, and so it might be a little bit more challenging to assess students' individual understanding of what they're working with and how it works. So having this as a complement to assessment of the project itself is a really good way to understand that individual assessment aspect.
Yeah. And I've used visual programming here, but, you know, you could do that in Python. So the question one of the teachers had watching, you know, can we do that with Python? You could take a string of text coding and say, you know, what would the output be? Again, it's just the same sort of idea, just transferring it to the text-based programming. You could have, you know, a number of sections of the code with something which would be one of the outputs, and say what what would be output in this part of the code, for example, or it could be in Python, it could be this code is not working. So, how would you fix this code to actually work, depending on what your students were doing. So there's quite a bit you could do in terms of if it was text-based programming.
And code comprehension is a really important skill. We often focus on the writing of code, but even having students read through, trace through code, so line by line, and understanding what's happening in that code, so what the output is or what the reaction is. And you can do that across all different year levels, from Scratch Junior by having the little coding blocks in a sequence, so you get them to predict what's happening in that animation, right up until general purpose programming or object-oriented programming as well.
I'll just make the point too here that if in year 7 and 8 you are doing sort of robotics programming and it is the visual programming, obviously you're not fulfilling the exact need of in terms of using a text-based language, but you are still getting that the thinking behind and the debugging and all that sort of stuff. But to be really ticking off the box for year 7 and 8, you need to be doing text-based programming. So thanks for that question about the Python. Hopefully we answered that. We also will be coming up with some assessment tasks for programming with text-based language, so bear with us. We'll definitely get some of those out. So in terms of a robotics project for years 7 and 8, for example, here's an example where you might come up with an idea that you're gamifying it. You can sort of say, well, the idea here is to get at least 50 points for your assessment, and they can choose any task. So, for example, you might use something like a driving test, give them, say 15 points, and they've made an autonomous vehicle, but they have to test it, drive it 3 laps around a loop, and obviously if it stays in that loop, then obviously it works, and that could be part of their 15 points. You might have students who have not done any programming of robotics at all, and just getting it moving forwards and backwards would be a challenge. So to 10 points for that particular idea. You might get students who want to pick up a payload again, so you've increased on that example there. But you could also have something like draw or write an algorithm for some points. So, we're trying to get not just the programming side of things, what's the algorithm, and, there's points towards that. We've got here one, the coding ninja. So you're helping other groups out. You're actually getting some points to help out groups who can't do the coding or have struck a problem. You might have some other kids helping them out in terms of, one group helping out another group. Again, it's good. Students to learn to share their ideas and knowledge, and I think they love to do that. A group of reflection, they could score some points. Again, with this whole sort of project-based work, you can design, assessment with students in mind, and with negotiating how might they look at a rubric, as Beck said before. What would 50 points look like, and how do we sort of assess that? So I'm noticing, Beck, we're coming up towards the end. I just want to quickly zip through a bit more.
Yeah, we can through these ones. So I guess on the next slide, we just want to leave you with thinking of how you might engage students in assessment. So again, not something that is at the end, but how might you engage students through that process? So you could get them doing self-ratings on their confidence over a unit of work. You might get them to do some reflections on their learning processes, and as well as their skills and content knowledge. You get them to co-construct, as we've mentioned. Perhaps even how they're using feedback. So if you're giving them feedback on a programming project or a topic, you might ask them to reflect on how they've used that feedback to move forward.
Yep.
So I think the next one. So I guess I'd really like just to emphasise as well, to come back to the achievement standards and the content descriptors, whatever curriculum that you're using, and really focus on, what are the key elements, because as you can see there, for F to 2, there's not a lot of text there. And so when you think of assessment, it's really honing in on that and unpicking it a little bit, You're not going to address everything in one lesson, or perhaps even one unit of work you might not get through all of it, but you're sort of picking out bits and pieces and identifying progression or skills and knowledge that you're looking for. So in terms of unpacking the assessment activities that we've been working on, we take pieces of the achievement standards as a single, or you might use a number of them together. We've just, on this screen here, you can see just a single piece of text from the achievement standard. And we've got here, describe how a range of digital systems and their peripheral devices can be used for different purposes. So I just want to, have a quick think, what's the key verb there that you're going to be designing your assessment activities around? What are you looking for students to do? What content knowledge and skills are you wanting students to demonstrate in their learning? So on the next slide, we've got here, the key verb here is describe. So we want opportunities where students can describe, perhaps in addition to some practical activities that demonstrate their skills. And then here you can see digital systems, and looking around peripheral devices, hardware and software are the focus there. So from using that, we can start to think about generating assessments. So the process we've taken is to focus on those key verbs using the Bloom's taxonomy that you'll have in your handout. The resource there, we've looked at, all right, this is in the understanding category. From there, we can think of activities where perhaps students are doing things like demonstrations, concept maps, producing some kind of video or text, and from their assessment, what kinds of things you might be looking for. So, for example, in the this achievement standard for describing how a range of digital systems and peripheral devices can be used, you might be thinking of these kinds of things like concept maps, discussions. But then, so taking that idea, looking at what kind of activities we might do, we might think, all right, so going back to this example, we might invite students to keep a log of devices, digital systems, hardware and software that they use throughout their day, and then they have to do a narrative or perhaps a video describing what their day looked like. They could keep a log, a journal, a reflective journal. They might take photos and things like that, and then present that as a video. So we've presented this using this framework, and we hope that it helps teachers in generating their own assessment approaches as well for their classroom needs.
And Beck, just lastly, with that digital systems one, there is an example there that they could go through and use it as a guide and a basis to do their assessment. So one last thing I wanted to say was all the lesson ideas that we've got, there's about 140 of them, they've all got assessment ideas in there as a starting point. We are putting up a whole lot of new work that Beck and I have worked on for quite a while now, so that'll be up before December, so keep an eye out for that. Hopefully, if you were a bit confused about assessment, we're giving you some way forward. So hopefully you've changed your viewpoint, or if you're already confident, you're a little bit more confident to what to do. Connect with us. We're more than happy to help out and to provide some guidance where possible.
Yeah, and I just, if you're looking for the resources with the CSER group, if you go to caesarmoocs.adelaide.edu.au, you can subscribe to our e-newsletter. Within the next e-newsletter that goes out, we'll be linking to this video, the handouts, as well as some bonus assessment materials. So we've got an assessment quick guide, and if you're familiar with our Peel in a Box, we create free peel packs that you can download and run sessions with. So there'll be an assessment peel in a box, so you can run an assessment session with the resources we've made for you in your schools. Fantastic.
And Beck, we're running a little bit over time, but they've all stayed with us, so it must have been pretty good. So appreciate people watching, and again at the end of this there'll be a little short survey if there's anything else you want us to provide in webinars later on, or have just got some questions about assessment, put them in. But thank you very much, Beck, and it's been fabulous working with you. Hopefully we've covered enough ground that people got a good sense of what to do with their assessment, but we'll speak soon. So thanks very much.
Great working with you, Martin.
No worries.
Thanks, everyone.
Look forward to our next webinar. Okay, thanks very much, everyone.